All right, page 29 in your textbooks, and your homework was to do page 29, numbers 2 through 36, the even, except for number 32. Let you skip that one, and then page 28, numbers 1 through 11, the odd. But we're going to start on page 29 with the 2 to 36 even. So in your spirals, find where you worked those. Bueno. You even started 32 and everything, and then halfway through you're like, oh yeah, Maddie's fault. We're blaming Maddie. All right. Why not? So I talked to Brecken yesterday. It was good to chat with him. And Brandon, you came up in course of conversation. I don't even remember how. He's like, I was like, do you know Brandon? He's like, no, I don't know Brandon.
28.
Oh, I see. Okay, I got you. Okay. And it's like, no, but I hear his name an awful lot. So anyway, I told him, you two will get this. I told him that Brandon is this year's Brecken. So is that fair? That's not fair. Yeah. Since Brecken was my favorite student last year, you're not here, you can't be my favorite. But Brandon's my favorite student this year. So that's
I'm honored.
He's all choked up with emotion. All right, number 2. Speaking of choked up, it can be arranged. All right, number 2. It's okay. Grace Christian School is a bully-free zone. You don't have to worry about bullying here at Grace.
I know.
All right. Number 2 on your homework, you're rewriting without negative exponents. Maddie, what did you get for your answer? Fantastic job. B cubed x to the 7th over d to the 5th. Number 4. That's a weird looking one. What did you get for this one, Abby?
G to the 24th, h to the 17th, w to the 24th over c cubed v x to the 6th.
And Brecken's like, he totally missed his shot. If I were in his class, he'd have said, oh, number 4 is a weird looking one. Speaking of weird looking ones, Brecken, why don't you do this one for us? I'm sorry. I should have done it to Brandon. And I called on Abby before I even thought about it. I'm slipping. Pray for me, Brecken.
Don't.
All right. Brandon doesn't want you to pray for me. Gavin will pray for me. All right. Number 6. That is correct, though. G to the 24th, h to the 17th, w to the 24th, all over c cubed v x to the 6th. Number 6, Michael, what'd you get? Rewriting without denominators.
G to the 6th, f squared, g cubed, and x to the 7th.
Excellent. G to the 6th, f squared, g cubed, x to the 7th. And number 8, Noah.
H to the 8th over cube g squared.
Well, remember it said no denominators, so we already kind of slipped up there the fact that you had a denominator at all. Did a great job with the h to the 8th. Audrey? Genesis.
V squared, V squared h to the 18th cube, 3, v to the 4th. Maybe not v to the 4th.
Yeah, something. Okay, Brandon, save us, rescue us here.
Right, h to the 8th, cube, negative cube, and v to the 6th.
There we go. Except we'd say to the negative 3rd. But otherwise, fantastic job. See, this is why you're my favorite student. H to the 8th, Q to the negative 3rd, and V to the 6th. Let's take a look at this one, because it messed up a lot of us. And then we'll take other questions in just a moment. Now, again, the key here is it said no denominators. Okay, so we can't have anything over anything. So everything here has to move up. This has to move up. This has to move up. This has to move up. When we do, it becomes h to the positive 18th and h to the negative 10th. A q to the negative 3rd. The v squared and a v to the positive 4th. Does that make sense? That's just everything moving up. Now, these are like bases. We would do what with the exponents here, class? Combine them or add the exponents, right? But because one's positive, one's negative, when we do an 18 and a negative 10, we combine that. It gives us just h to the 8th. The q to the negative 3rd has no friends. I'm resisting the urge. And v squared, it's an old joke anyway. It's been so overused, we might as well move on from it. And then v squared, that's how it came up in course of conversation. I was going over one of his quizzes with it, and I'm like, such and such has no friends. It's Speaking of which, do you know Brandon? And that's how I came on. Well, because I pick on you so much with that comment, so I was like trying to draw his memory back to other videos we've done already. Anyway, and then here, class, we'll add the exponents together.
Move. I don't want to be the third.
You think it's because of where you sit? It might be, actually, because you're right in my line of sight. Like, they're sitting over there just minding their own business, and you're right there. Anyway, what did we get right here, class? B squared, b to the fourth?
B to the sixth.
B to the sixth. All right, and that should have been our answer. Does number 8 make sense to all of us now, since many of us missed? At least 4 of you did. Did you happen to get it right? No, you didn't either.
I got it
I
right.
got B to the negative second.
Oh, yeah, see, that's not what it is. So you were the only, you got it?
Yeah.
Oh, that's right. Noah was the first one I called. And I thought I started with you and it worked around until we got, okay. So 2 of you got it right. Good job, guys. Way to represent. All right. None of the girls got it. Let's see. Questions on 2, 4, or 6. Do we need to see any of those ones worked out? 2, 4, or 6? Trying to do some semblance of seriousness here. All right. Failing miserably. I can't do it. Number 10. Let's go back to Noah, who needs redemption, because he was the only guy who didn't get it right on number 8. Number 10. Noah. Y is negative 4. What do we get when we evaluate?
31.
No. Audrey? 119 is correct. Let's take a look at this one real quick. Again, all you have to do, Noah, is plug in negative 4 everywhere you see y. So not negative 10y, but negative 10, negative 4. Plus 11, not y, but negative 4. Minus not y squared, but negative 4 squared. All over not y, but negative 4. And then minus not y cubed, but negative 4 cubed. So really the key is to keep track of that negative. So as we go, Noah, negative 4 times 11. 11 times negative 4?
44.
Sounds different?
Negative.
Negative 44. Minus, and then we have to square negative 4. What is negative 4 quantity squared?
16.
A positive 16. And it says we're subtracting. In class we never really subtract. We have the inverse. We're going to make this adding a negative. All over negative 4. And then here we've got minus, and it's negative 4 quantity cubed. What would that give us, Noah?
16.
But the negative, there's 3 negatives, right? Negative once, negative twice, negative thrice. So an odd number of negatives gives me negative 64. Once again, it says we're subtracting. Class, we never really subtract. We add the inverse again. And so it's going to become a positive 64. And right here, we have to multiply Noah to get positive 40. We can combine the negative 44 and negative 16, class, to get negative 60. Divide that by negative 4 to get, think of a clock, 60 minutes divided 4 ways. 1 football game divided in quarters? 15 minutes, there we go, 15-minute quarters. So positive 15, we got a positive 64, I love football, and 40. We add it all together and there's our 119. For redemption, Noah, if y is 5, there's no negative this time. Here we go. If y is 5, what you have to do is read your answer. For 10b,
No.
you skipped 10b. You
I only saw the first one.
slob. Let's see, Genesis, what do we get for 10b?
I got 133.
No, Maddie? Negative 169 should have been our answer there. So when we plug in the 5, I'm going to do it the faster way this time. Negative 10 times 5 is negative 50. We've got an 11 times 5 is 55, minus 5 squared, which is 25 all over 5. And then minus 5 cubed is 125. Here we subtract to get 30. Divided by 5 is 6. So it's negative 50, positive 6, negative 125. Gives us negative 169. Number 12. We're adding 2 polynomials together, combining the like terms. What do we get for number 12? Noah?
5y squared negative 2y negative 7.
There we go. Third tries the chart. 5y squared negative 2y negative 7. Number 14. Let's go back to Genesis. We had to distribute a negative 3, distribute a negative 5, then combine like terms.
17u squared plus 26u plus 33.
You're right about the plus 33. Let's check your distribution. When you distributed the negative 3, what did you get?
Negative 27u squared. Negative 36u. Positive 18.
Okay, and then when you distributed the negative 5,
Positive 10
oh,
squared.
positive 5 times 10, 50 u squared.
Negative 10u positive
Okay, so you correctly got the 33 here. Here you had the negative 10, but for some reason, instead of saying, okay, signs are the same, add and keep the sign for negative 46, you subtracted and got negative 26. So that's what happened there. And then here we just forgot to actually multiply. That's where your 10 came from for the 17 instead of a positive 23 u squared. So this should have been our answer here on number 14. Number 16 for redemption Genesis. When you distribute, you got?
Negative 12x to the 6, positive 18 to the 4, negative 24 cubed.
Negative 24x cubed?
Yes, x cubed.
Say that answer one more time. I looked over at the tablet for a second there. I thought I'd forgot to start recording, and then I realized, no, we're good. So try that one more time.
Negative 12x to the 6, positive 18, x to the 4th, negative 24x cubed.
Look at your very first exponent. Remember when we multiply like bases, we add the exponent. So a cubed times a square doesn't give you a 6, but to a fifth. Negative 12x to the fifth. Positive 18x to the fourth, negative 24x cubed. Number 18. What is that thing in number 18, Abby?
Conjugates.
Conjugates, or a sum and difference. And we multiply conjugates, class, 3 steps. Square the first, square the last, put a minus sign between them. Abby, what do we get for our difference of squares?
A squared negative 144.
Great job. A squared negative 144. How about number 20? Another pair of conjugates, Michael.
N squared negative 81.
Great job. N squared negative 81. Number 22, they're similar binomials at least, so we can FOIL them. Noah?
X squared positive 16x negative 20.
Positive 16x. What's your outer?
X squared.
Your outer. Your
2x.
negative 2, or positive 2x, right? And then your inner,
Negative 10.
negative 10x. I don't see how you got a 16 from that. I'm pretty sure you meant to get
8.
negative 8x. Good, but you were correct about the negative 20. And then look at your first. We have negative x times negative x. I think you actually said x squared, positive x squared. And this should have been our answer there for number 22. Number 24, Audrey.
Negative 21x squared plus 96x negative 48.
Great job. Negative 21x squared, positive 96x, negative 48. Number 26, more FOIL. Genesis.
20x squared plus 12x z plus 32 z to the z.
Look at your outer. What's our outer supposed to be?
32xz.
Negative 32xz. What's the inner supposed to be?
Negative 20x.
Right. Yeah, and that's what happened. You had a positive 32 in your mind with the negative 20 gave you 12. Should have had negative 20, negative 32 for a negative 52. xz. 20x squared, negative 52xz, positive 32z squared, our answer for 26. Number 28, we had a double distribution to do. And Genesis, what did you get on this?
28
Number 28, yes.
x cubed negative 6x squared plus 19x minus 6.
So close, Brandon.
It's a negative 19x.
Negative 19x. Look at your partial products. Were they both negative? Add and keep the sign. Oh, you had it too. X cubed, negative 6x squared, negative 19x, or negative 6. Number 30, triple distribution. Brandon.
Negative x to the 4th plus x cubed, negative 12x squared, negative 78x, negative 108.
Two little mistakes there. Maddie, your answer.
Negative x to the 4th positive x cubed negative 78x positive.
Right, at the end should be a positive 108, and then where you had a 12x squared or negative 12x squared, we should have had two things that were inverses that should have canceled. So a 6x squared and a negative 6x squared should have canceled completely. You somehow got a 12x squared from that. Do you see it? Your very first, when you did your third distribution, negative 6 and negative x squared should have started you with a positive 6x squared. I got a feeling you had a negative. Okay, so you did it off to the side. Gotcha. So right, yeah, here it is. So negative 6, negative x squared, positive 6x squared, negative 7, saying positive. That's the one thing that messed you up. And then on the end, the negative 108. So one more time. I'm going to give that answer so the camera can hear it. Negative x to the 4th, positive x cubed, negative 78x, positive 108. We skipped to number 32. Number 34, squaring a binomial. When we square a binomial, class, 3 steps.
Square the first, square the last, multiply.
That was weak. Class, what are my 3 steps to squaring a binomial?
Square the first, square the last, multiplying down.
And when we square a binomial, class, we always wind up with a
Perfect square trinomial.
Perfect square trinomial. Class, what do we get when we square a binomial?
Perfect square trinomial.
There we go. So we should get a perfect square trinomial here on number 34. And what did Maddie get?
X squared positive 10 xy plus 25.
I swear you sound like you're doing that on purpose. X squared positive 10 xy positive 25 y squared is correct. And then number 36, another binomial squared, Abby.
16m squared negative 16mn positive 4n squared.
Good. 16m squared negative 16mn positive 4n squared. All right. Anybody? I don't think anyone was perfect on the homework. Sound like at least everybody missed one? Anyone perfect? And I'm just missing. How about miss just one or two? Just one or two things on the entire homework assignment. 3 or 4? Okay. Questions on any of the things? I know we covered a lot of stuff up here already. Is there anything we did not cover you still have a question on? Going once on questions. Twice on questions. Twice on questions. You know, I'm having all this trouble after I chatted with Brecken yesterday. I'm like, anyway, I'll find a way to plug this on here. Turn back, or look back across the page. Page 28, numbers 1 through 11 odd. Yesterday, introduced to you this idea of taking a polynomial and breaking it up, in a sense, into its parts. What is this process called whereby a polynomial is broken up into multiplied parts? Anyone? Factoring. And the first method that we talked about with factoring was simply pulling out a common monomial factor. On number 1 from the homework, you were given a 2x negative 8. You were supposed to identify what was common, Michael. And what's common to 2x negative 8?
2.
And when you factor out the 2, what's the other factor you're left with?
X minus 4.
And basically, to get the x negative 4, you just divide by whatever common factor you've identified, because factoring is division. In a sense, you're also undistributing. You realize you could distribute a 2 to get 2x negative 8. You were undistributing, pulling the 2 back out of the 2x negative 8. On number 3, what was the common factor, Noah?
5x.
And it left you with?
X plus 9.
As your other factor. Number 5, the common factor, Audrey.
X.
And then the remaining factor.
4y plus 1.
Great job. Not 4y, but 4y negative 1. When you pull the x out of itself, you're dividing something by itself, leaves you with the 1. Number 7, Genesis, what was the common factor?
7.
Well, look at the last term on number 7. I've got a 35 in the first term, I've got a 7 in the next term, but I don't have a 7 in the last term, do I? So I can't pull out a 7. Is there anything common?
X.
There is an x. Anything else?
Y.
And y. And of course, you don't just want to write the letters, you want to find how many x's are common at most. How many y's common? In this case, it is just one of each. And we factor out the xy, Genesis, dividing out the xy. What are we left with for our other factor?
35 x cubed y to the 5th plus 7x y plus 1.
Well, not plus 1.
Oh,
Minus 1. Good, because you're dividing the negative by the positive to get the negative 1. For number 9, it's not a common monomial factor, but a common binomial factor. Brandon?
And then in parentheses, d squared plus 2.
Number 9, let's just, what's common to both of those terms?
D.
Well, I don't have just a D. I've got there's a grouping here. What grouping is common to both terms?
The d plus 1.
The D plus 1. So I don't actually have a D, I have a D plus 1, because it's all grouped. We can't call it just a D, because it's grouped together. So since both terms have a D plus 1, just like, for instance, here I had 4xy, negative x, and I said, hey, they both have an x. I write the x out here, and it's as if I just pull the x right off the board, and all that's left is the 4y, and then the one that could have been understood before. So we're going to do the same thing here. The common factor is the D plus 1. And if we were to pull the D plus 1s off the board, what would be left right here?
C minus 5.
C minus 5. And that's what we should have gotten for our answer. Does that make sense now?
I multiplied since there's 2 of them.
Right, but you're only pulling out a single D plus 1. Does that make sense? Okay. So for number 11, what should we have gotten for our answer?
R minus 5 and then R plus 7.
Good. R negative 5 times the quantity R plus 7 should have been our answer on 11. And it would go 6 for 6 on 1 through 11, the odd. All right, any questions on those odd problems? Any questions at all on that? Write this down in your notes if you would. 18 x cubed y to the 5th minus 16 x squared y to the 8th plus 10 x to the 4th y cubed. What is the common factor here, Abby?
2x squared y to the 3rd.
Good, and I like how she went through it. She didn't try to give me an answer all at once. Don't spend a long time looking and trying to figure out the entire monomial. Go sine maybe-ish, usually not sine, unless there's a leading negative maybe. Number, well there's at least a 2, write it down. X, there's at least 2 of them. Y's, there's at least 3 of them. Get it that way. And then, to get the remaining polynomial factor, we just do what with the 2x squared y cubed, Maddie? Sign number letter we, it's factoring, we class, divide it out. Factoring is division. So go ahead and divide that out now, Maddie.
8
Good, because those x's canceled.
positive 5x squared.
And y cubes canceled. Questions on this? Enter seats to 8 and 12. 8 and 12. They're on page 28. I'm glad you're here. You're not upset. Well, I'm having fun at least, so thank you for being here. I was told by my sisters, hey, if you're not picked on, you're not loved, so you just must be really loved because I pick on you a lot. Like Kendall. We love Kendall. A lot. All right, let's go and take a look at our answers. Number 8, what did you get for your answer, Michael?
I got 5x squared y cubed times the quantity of 3x, 20x to the 22nd power y to the 9th plus 9x to the 4th y cubed minus 2.
Great job. 5x squared y cubed times the quantity 3x to the 22nd y to the 9th plus 9x to the 4th y cubed minus 2. All right, and then number 12, what did you get for your answer, Genesis?
Negative 40q times quantity 2m plus 3.
Oh, I see what you did. Okay, so Genesis, we've got the 8q 2m plus 3 minus 5 times 2m plus 3. And you said what's common?
The 2m plus 3.
The 2m plus 3. So just like we would write any other common factor down, write that down first. Then, in parentheses, write down everything that's left. What's left after the 2m plus 3 has been taken out? 8q negative 5. And you tried to multiply to get a negative 40q. They're not being multiplied, they're two separate terms. So we'll just leave the 8q negative 5. Does that make sense? How many got this answer there on 12? All right. Question?
I did the wrong problem.
Did the wrong problem. All right. I was about to say, I wrote it right there. I didn't write it right there. That's my fault. I should have written it right there. All right. I want to take you back to your junior high days. I think prime factoring was a junior high concept. I don't know that you did this in 6th grade, but it's been a long time, so I can't remember for sure. 10, right, factors into 2 times 5 if you prime factor. 25 factors into 5 times 5. But because mathematicians are lazy, they typically wouldn't write 5 times 5, class. They would write 5 squared, right? Because 25 is a perfect square. It factors into a value squared. Does that make sense? Well, just as 5 squared gives 25, if we took some binomial like x plus 3 and squared it, we know we would square the first, square the last, multiply and double, and we get something called class A, perfect square trinomial. And just as a perfect square like 25 can factor into 5 squared, so a perfect square trinomial can factor into a binomial squared. So the next thing in your notes, factoring a perfect square trinomial. Factoring a perfect square trinomial. Factoring a perfect square trinomial. Put a star next to this. A PST, which is how lazy me is going to put it, a PST factors into a binomial squared. A PST factors into a binomial squared. And this is the lazy geometry shorthand way of doing it. For those veterans of geometry, you know what I'm talking about. All right, so a perfect square trinomial factors into a binomial squared. Now, the question is, how do you know something's a perfect square trinomial? For instance, if I gave you the number, I don't know, 529, is that a square? How do you know? Well, it is. It's 23 squared, but how are you supposed to know that, right? Unless you happened to memorize it. Well, the same could be true for a trinomial, like perfect square trinomial. Okay, great, I know it's got 3 terms, but how do I know by looking at it that it's a PST? 4 things you're looking for. First of all, a perfect square trinomial, remember it's square the first, square the last. Because of that, both the first and last terms must be in themselves perfect squares. You're checking, first of all, to see if the first and last term are perfect squares, because you would have had to square the first and square the last to get them. Also, because a perfect square trinomial has a square, remember we said the last sign is always a positive? So we're checking to see, do we have a perfect square here? Do we have a perfect square here? Do we have a positive here? And the last thing, remember we said we're going to multiply and double, which means times 2. Anytime you multiply by 2, you get an even number. So the final check is to see, is the middle term's numerical coefficient even? 4 things we're looking for. Perfect square, positive, even. I'd say about 90% of the time, if those 4 things check out, you have a perfect square trinomial, which can factor into a binomial squared. So for instance, write this down in your paper. 4m squared negative 20m positive 25. Obviously, it's a trinomial. I see the 3 terms. Is it a perfect square trinomial? 4 things we're looking for. Say them with me, class. Perfect square, positive, even. Again, perfect square, positive, even. Do all 4 things check out, class? Yeah. Now, that doesn't guarantee you it's a PST, but 90% of the time, something like this is going to be a PST. And if it's a PST class, it factors into a binomial squared. So how do we go about getting the binomial squared? Well, you know how we said square the first, square the last, multiply and double? Take the square root of the first. Well, what would be the square root of 4m squared, class? 2m. Take the square root of the last, class, 5. And then whatever sign is in the middle came because of this sign, right? So whatever sign is in the middle term, you bring down. So 2m negative 5. Now, how do you check? Because remember, I said it's only 90% of the time, right? Try multiply and double and see if it checks. 5 times 2, doubled. There's the negative, there's the m. Yeah, this is correct. There's my binomial squared. Does that make sense? So square root of the first, square root of the last, bring down that middle sign, and then use the multiply and double as a way of checking to make sure it really was a PST. Write this one down. C to the 4th, positive 12, c squared d, negative 36, d squared. C to the 4th, positive 12, c squared d, negative 36, d squared. I want you to write this statement in your notes. All even powers are squares. All even powers are squares. Any even power could be written as some other power squared. For instance, d squared would be d to the 1st squared. D to the 14th would be d to the 7th squared, right? Because when you square something, you're raising that power to a power. Just multiply the exponent, so something multiplied by 2. All even powers are squares. So, is this a perfect square, class? Yeah. Is this a perfect square? Yes. Positive? Oh, no. Is this a perfect square trinomial?
No.
Then is it going to factor into a binomial squared?
No.
No. All right, perfect square positive? Yes. Even? Okay, now it looks like a perfect square trinomial, and if it's a perfect square trinomial class, it factors into a binomial squared. So set up your parentheses, put your little squared outside. By the way, I can't tell you how many students will set up the binomial and forget to write squared. So I do that before I do any of the other work, so I don't forget. And we'll take the square root of the first term. Remember, that means you're going to cut the exponent in half.
C squared.
So you get a c squared. C squared squared would have given me that c to the fourth. We'll take the square of the last term. 6d. And then what sign goes in the middle? How do we know it's a positive, Noah? The middle sign is positive. We're going to keep it. Let's check real quick. If we multiply and double, do I get a positive 12c squared d class? Yes. Then I did it correctly. Everything's good to go. Write this one down. M squared, negative 6mn, positive 16n squared. M squared, negative 6mn, positive 16n squared. 4 things we're looking for, class. Perfect square, positive, even. Do all 4 things check?
Yes.
All right, then probably it's a perfect square trinomial, so we're going to factor it into a binomial squared. I take the square of the first term. I take the square of the last term. 4, and I put a negative in between them. And I'm going to check, multiply and double. Do I get a negative 6mn? No. What do I get? Negative 8mn. If this were an 8, it would have been a perfect square trinomial. This is one of those 10%ers. It looks like a PST. Everything looks good. It ain't a PST. So for now, we'll just say, well, we can't factor it. I'll show you later how we will. Some of you might remember from past years how. But for now, we'll just say, well, we just don't factor it then. And that's why you do the double check. Because it meets all the criteria to be a PST. But again, there's about those 10% in there that we'll see that just don't measure up. Write this one down. 16x squared, negative 24xy cubed, positive 9y to the 6th. PST, yay or nay? Audrey? Yay, it is. Matches, at least it looks like it, right? So if it's a PST class, factor it into a binomial squared. Parentheses with a little squared outside. What goes in the parentheses, Brandon?
4x and negative 3 and 3y squared cubed.
Cubed. Good. Remember, you're going to divide the exponent in half because a y cubed squared would have given me the y to the 6th. So since we double the exponent to square it, to take the square root, we cut it in half. And we check real quick. Would this multiplied and doubled give me that class? Then we're good to go. Questions on turning a PST into a binomial squared. We should remember this from past years. How many say, yeah, I think I got it, I think I remember it. Is this new to anyone in here? Say, I've never learned this before. Does it make sense to you? All right? Now, I want you to write this statement in your notes. Always factor out common factors first, and underline the word first. Always factor out common factors first. Always factor out common factors first. Then write this down. 3r squared, negative 6r, positive 3. This is definitely not a perfect square trinomial, right? No way. Not a perfect square, not a perfect square. It is positive and it is even, but no PST. Well, let me ask you, is 12 a perfect square? No. But if I factored it 3 times 4, there's a perfect square hiding inside that could turn into a 2 squared. 12 is not 2 squared, it's 3 times 2 squared, right? But there's a perfect square inside 12. Oftentimes you'll come across things that, okay, no, it's not a PST, but there's a perfect square trinomial inside if we'll just factor out the common factor of 3. And if I pull out the 3, Genesis, what's left in the parentheses? And now we see perfect square, positive, even. Does that make sense? So factoring out the common factor first opens up the possibility. Now let's suppose we had a number like, trying to come up with something here, I don't know, 64. And you're like, hey, 64 is a perfect square. But suppose you could factor in a 4 times 16. Well, you still have a perfect square. In fact, you got a couple of them here, right? Sometimes that may happen. Okay, so we'll see later on perfect square trinomials that even once you pull out a perfect square factor, you may still have a PST there. Let's go ahead and keep the 3 though. Just like here, it's not 2 squared, it's bring down the 3 times 2 squared, right? Bring down the 3 and now turn this PST into a binomial squared. Michael, what goes in the parentheses?
R minus 1.
Good. And if we multiplied and doubled, would we get a negative 2r class?
Yes.
Yes. So there's our factor form. Make sure this example is in your notes. Another one for you to write down. 2x, negative 20, a squared x, positive 50, a to the 4th x. PST class? This is a perfect square? No, that's not a perfect square. It's positive and even. But what's the first thing we always check for when we factor, class? Common factor. What do we check for first? Common factors. Noah, what's common? A 2 and an x. So if we factor out 2x, Noah, what does that leave us with? Now do we have a perfect square trinomial class?
Yes.
Yeah, perfect square, 1 squared, perfect square, positive, even. Now, will you always get a PST every time you pull out a common factor? Of course not. We did a whole lot of stuff last night for homework where we pulled out common factors. There weren't any PSTs, but it can happen. So the point is just watch for it. And if we have a PST class that factors into a binomial squared, and we take the square of the first, square of the last, sign of the middle, and what do we get in our parentheses, Maddie? And there's our answer. Questions, comments? There should be a comment. Right. This is not our answer. This is just this part of the answer. Don't forget to bring down the 2x. So my strategy, last time I brought down the 3 before I formed the binomial squared. Bring down the common factor before you fill in your binomial squared. Otherwise, you're more likely to move on to the next problem on a quiz or test and totally forget it and lose points. And that's sad. Questions on this one? All right, write this one down. Now we're going to show a little bit of a weird twist here. X to the 2r minus 8x to the rz positive 16z squared. Is that a square? Well, remember I said all even powers are squares, right? Is 2r even? Well, for any integer times 2, it'll always be even. So yes, this is even. So we do have a perfect square. Of course, perfect square, positive, even. So we can form a binomial squared here. Remember I said cut the exponent in half when you take the square root. So when I take the square root of x to the 2r class, I would get x to the r. Of course, the sign and the square to the last. 4z. And sure enough, if you multiply and double, you get the negative 8x to the rz. Questions on what to do with literal exponents? Don't let them faze you. Go with what you know to do. You might even see something horrid like this. A plus b quantity squared minus 4m times the quantity a plus b plus 4m squared. Hideous and generally scary. Well, how many terms do we have? 3. 1, 2, 3. That's a trinomial. Is this a perfect square? I have an even exponent. Is this a perfect square? Positive? Even? Perfect square trinomial. So class, that means it's going to factor into a binomial squared. What's the square root of a plus b squared? A plus b. What's the square root of 4m squared? 2m. What sign do I put in the middle?
Negative.
Try the multiply and double. Negative 2m times a plus b doubled. Would it be negative 4m a plus b?
Yes.
Yeah. And if you wanted to, because the parentheses are preceded by an understood positive, you could drop the parentheses and write your answer as a trinomial squared, a plus b minus 2m all squared. You don't necessarily have to take the parentheses off, though. So even something hideous like this, we can handle in Algebra 2. Questions on this? All right, let me give you some of these to try on your own now. You've been watching and doing with me for a while. Your turn to do these on your own. x to the fourth, positive 4x squared, positive 4, and then I'll be putting up more as you work. All right, check your answers. Even if you're not finished, go put your pencil down, check the ones you got done, and then take a look at the ones maybe you didn't get a chance to get to. How many got all the ones you did correct? All the ones you got to were correct. All right, which ones did we miss? Okay, which ones were missed that we did?
The one with 3a, but I just got a plus 16 instead.
Oh, okay, so you forgot to take the square root of the 16 to get the 4. Okay, all right, anyone else? All right, of the ones you did not get to, take a moment to look at them. Are there any questions of the ones we didn't quite finish? The ones we did not finish, are there any questions on those, or do we understand exactly what to do? Any questions? How many did finish all of them? Okay, only a couple of you. How many got 5 of them done? Maybe just that last one didn't quite get to it. 4 out of 6 got the top row done. Did you get any of them done?
I got 2.
Okay, well, we want to be much faster than that, right? Is there some question where you're like, I just didn't quite get this and it was slowing me down?
I forgot to factor the second one first and I got really confused.
Ah, gotcha. Yeah, always factor out the of the 6, 3 of them had a common factor, right? They won't always have common factors, but certainly look for those first. So we learned a lesson from it, right?
Yep.
All right, any other questions? Next section, your notes. Next section, your notes. You'll recall that if I had something like an x plus 4, and I multiplied it by an x negative 4, I would get x squared negative 16, right? We would square the first, square the last, put a minus sign between them when we multiplied a pair of conjugates. And what we got was something we call class A difference of squares, right? We understand you should be able to flip that process around then. You should be able to take a difference of squares and factor it back into a pair of conjugates or into a sum and difference. If the one multiplied gives this, then this should be able to factor back into that. So the next section of your notes is factoring a difference of squares. A difference of squares. And just write down that a difference of squares factors into a sum and difference. A difference of squares factors into a sum and difference. A difference of squares factors into a sum and difference. How do you recognize a difference of squares? Well, it's a difference, minus sign, between two squares, like 4m squared and 25. And if you have a difference of squares, class it factors into a sum and difference, which means you're going to need two sets of parentheses. One with a plus, sum. One with a minus, difference. Make sense? And then just as we said we'd square the first, square the last, and put the minus sign, then what we're going to have to do is take the square root of the first class, and we're going to put that at the beginning of both binomials, and take the square root of the last, and put that at the end of both binomials. And we're done. Just that easy. But what about something like this? Is this a difference of squares?
No.
Then it doesn't factor into a sum and difference, does it? But what's the first thing we should always check for when we factor, class? Common factor. And there is something common here, anyone? 2c. If we pull out the 2c, what are we left with, Maddie? Close. Help?
Square.
9c squared, negative 25. Ah, that is a difference of squares. That will factor, class, into a sum and difference. But don't forget to first bring down the common factor of 2c. And then set up your sum and difference. One binomial with a plus, one binomial with a minus. What goes in front of the plus and in front of the minus, class?
3c.
3c. What comes after the plus and minus? 5. And we factor our binomial. Okay, questions on that? Same thing as with the perfect square trinomial, right, Michael?
Yep.
They sometimes may have that common factor. Get it out first. Write this one down. X to the fourth minus 16y to the fourth. X to the fourth minus 16y to the fourth. Remember, you already wrote it down earlier today, all even powers are squares. So this is a square. That's a square. We've got a minus sign between them. Class, we call this a difference of squares. And a difference of squares factors into a sum and difference. And what do we put in front of the plus and minus, class? And what do we put after the plus and minus, class?
4 minus 1.
But, think for just a minute, if I factored like the number 30, and I factored into, say, I don't know, 5 times 6, have I factored the number 30? Have I factored completely? No, because the 6 can factor again, can't it? 2 times 3. The 5 doesn't. We'll just bring the 5 down, but the 6 could factor more. Do you notice we have another difference of squares here? It needs to factor into another sum and difference, class. What goes in front of the plus and minus now? X. What goes after the plus and minus? 2y. This is what we call a sum of squares. Write the statement in your notes. A sum of squares doesn't factor. A sum of squares doesn't factor. So, just like the 5, we brought it down. Just like common factors, we bring it down. We bring it down. And here's my fully factored form. Does that make sense? Okay, just keep factoring. If you want to write yourself a note, 4th powers and 8th powers will do this to you. 4th powers and 8th powers will do this to you, where you factor into a sum and difference, and oftentimes you're stuck with another difference of squares that has to factor again. Write this down. A to the 6th minus 36b squared. A to the 6th minus 36b squared. Difference of squares? Is this a square? All even powers are squares. So it is a difference of squares, Genesis, which means it will factor into a sum and difference. And what's our sum and difference going to be? There we go. A cubed and a cubed plus and minus 6b and 6b. I'll write this one down. X plus y squared minus 9z squared. X plus y quantity squared minus 9z squared. Is that a difference of squares?
Yes.
Because here's the square, minus, here's the square. Stay with me for just a moment longer. Well, it factors in with sum and difference, doesn't it? There's my plus, there's my minus. What goes in front of the plus and minus this time? The quantity x plus y, which we don't necessarily have to keep the parentheses since they'd be preceded by understood positives anyway. What goes after the plus and minus? 3z. And there we go. All right, did not get as far as I wanted to. I think I wasted time picking on Brandon at the beginning of the hour, and I need to stop it. Not so much for his sake, but so I can get through my notes. All right. Maybe for his sake, too. I don't know. Anyway, no homework this evening. I do have one extra credit for you, though, and that is page 28, number 29. Page 28, number 29 will be extra credit. Let me explain extra credit very quickly. If you get it right, you get 1 extra credit point on your first test coming up in another week and a half or so. If you get it wrong, no penalty. If you don't do it, no penalty. Just if you get it right, you get some extra credit. All right, have a wonderful rest of your day, and you are dismissed.